everyone. How's it going? My name is Robert Morris. I am actually a real person. Hi. And I wanted to talk to you today about how aerial imagery is getting used in agriculture, and a little bit on my background and the background of our company. So TerrAvion is actually the largest provider of aerial imagery to agriculture in the US. And we got this way by taking some of the lessons that I took from my service in the Army, where I led the Army's first drone platoon in Afghanistan, and applying that to agriculture. And I think that what's really relevant about what we're doing for the general AI audience is that, what we're doing is we're really building the feedstock for artificial intelligence and computer vision applications. I often compare us to the 21st century phosphate mine. It's not finished fertilizer, but we're getting the stuff that's required to actually deliver a useful product to growers. But we need sort of the rest of the industry to catch up and actually deliver finished liquid fertilizer. All right, so the key insight that I took away from my service in the Army is that imagery is really, really useful for controlling operations. I got to watch, drones go from a toy that's useless to we don't roll troops outside the wire without overhead coverage. And that just really changed sort of where the center of gravity for decision making was. And I'm proud to say that I think, at least for a small portion of growers, we've actually done the same thing in agriculture, and it's real. This idea that, hey, I have a map or a picture, and I know what's happening everywhere, and I don't have to go drive around to find out. I can start taking action. I guess the other thing that I took away is that drones are actually not economical, and I'll touch more on that. And so we actually used a manned aircraft-based solution because it's about, at least a factor of 10 cheaper on a per acre basis than drones. We built our system to sort of do a bunch of established science, but I think the thing that it does do that we really took from the military is not like literally the technology, but the mentality of, I think one of the things in civilian remote sensing science is that we really miss out on is the civilian attitude is, hey, the USGS created this giant data set, let's go analyze it. And the military says, hey, you know what, we want to find something out, let's go collect the data that would tell us the answer. And I think what we're really trying to do with this system is enable growers in particular, but I guess other people that are interested in what's going on in the world to sort of say, hey, let me go task a plane and go find out what's going on. And I think that imagery is the right tool for this. I know there's another talk going on right now about satellite, and I think that in general, imagery is a tool that allows people that are managing land to actually see what's going on. In a lot of agriculture, you literally cannot see what's going on in the middle of the field without an overhead view. And growers obviously use this in a really regimented way. This is a corn crop, and sort of the boxes are the decisions that the growers are making, and the gray bars are when we deliver imagery to corn growers, and then the bubbles are sort of the opportunities we see for growers to make a better decision on every field. And our take is that for a whole class of problems, satellite's just not good enough. I mean, this is the classic example we use, same field, same day. And I don't know if my cursor shows up. It appears it doesn't. But if you look in the TerrAvion image on the left side, there's a diagonal line through the field, and that's a pivot arm. But if you look around the pivot arm, there's actually probably a soil-induced variation that's large enough to do something about that is counter to the trend of satellite. It just doesn't show up. And so I think that that's sort of like a telling. There's a lot of problems that you just literally cannot solve from satellite. And I mean, here's a couple more examples. thermographic detection of irrigation problems, or even just small scale like weed or fungicide issues. You literally cannot see them from space in the time that you need to. And it turns out aerial gets pretty close to the cost of satellite and gives you this sort of, month lead on the problems that you're actually trying to solve. And I guess the other thing we always like to point out is that drones are not actually a scalable solution. The problem is that you have to send a dude in a truck to the field, and that's really expensive even if the drone isn't. And I just don't see drones, small electric drones anyway, being competitive. And this is a 2015, and we've been growing faster since then. So I think that this is this sort of relative difference between drones, and that's so when I wrote, you can read the blog post, but I was looking at mapping across all industries, and you can just see that like our company, forget all other aerial imagery providers, but our one company drones are a tiny little niche interest compared to what we're doing in terms of volume. And I guess what this really means for AI and computer vision practitioners is like, holy crap, there's a AWS utility that I can call that that will go out and look at the world, basically wherever there's irrigated agriculture, and soon in more places as well, that will deliver the kind of information that I need regularly at, literally cents per acre per pass. We know that imagery is like really useful, and that there is a super valuable and very tangible ROI. This is a bunch of links to the kinds of issues that we're looking at. I mean, I shared some pictures of what these things look like. Of like, hey, look, it's like a little spot in the field, but the ring is a characteristic pattern that almost always says it's related to the center pivot irrigation. And similarly with some of these disease outbreaks, a lot of diseases actually have characteristic patterns that come from whether they're mechanically spread or if they're soil borne. One of the things that there's some nematode issues, and nematodes also have a very characteristic pattern. It almost looks like water spotting on a piece of paper that's gotten wet. It's pretty neat. So I think that the right now imagery really state of the art is to have an expert going on in the field, look at the imagery, look at a bunch of other imagery, and use their experience plus what they know about the field. But I think that there's a huge opportunity for computer vision and AI practitioners to really push the state of the art here forward, and start being diagnostic, and also advise about things that are a little further afield of like almost nobody's using remote sensing now to assess risk at a field scale. Really only like a weather-based kind of risk assessment. And there's tremendous sort of like opportunities for computer vision to do pick off really simple tasks that we shouldn't have people doing. Right now, like in produce, for instance, this is just like our one afternoon demo of lettuce counting. And we're very interested in collecting the data, but maybe not in the counting. As you can see, we're not totally getting it right. In this picture, it's a thresholded near infrared image of lettuce at about 3 or 4 centimeters. And so the black is supposed to be background soil, and white is plant matter. And we just did a cluster count. And so you can see we missed some lettuce, and we double counted, and we counted some lettuce that's not viable. But I mean, this is just kind of to show that this is possible. Because right now, like, I mean, the price of produce fluctuates really wildly, like in a way that, if you think commodities trading of like, oh my gosh, the price of corn has fallen by half in the last three years or so. It's like that happens every single week in fresh produce, because you can't store it, and demand is constant and supply is not, and people miss it all the time. So I mean, this is just like the kind of thing that I think that we can really attack with having data at scale, and then having the analysis of it to say things about it. And I don't know if any of you shop at Walmart, but I shop at Walmart from time to time, and I have been amazed at sort of how inconsistent the produce like at the Walmart in the not so nice part of Oakland is. And I really think it is largely due to supply. Walmart is aware that its consumers are price sensitive, so it's only going to do cheap stuff. And so when the market is tight, they don't get good lettuce. And so since they can't count on having good lettuce, it's not part of their diet. And hence we have all these food deserts and obesity problems in the US. So I really think that AI and computer vision are a real chance to really make a difference in consumers' lives in terms of making a better, more stable supply chain. All right, so this is just us bragging about our reliability, that we're to the point where we can actually offer an SLA and actually deliver, an uptime. No, it's not 17 nines like AWS S3 has on their storage, but it's at least 2 nines, which 2 nines in remote sensing, where you have to deal with weather and natural conditions, is like this is an achievement I'm really proud of. Don't get me wrong, we're pushing for 3, but the point is that that's the kind of error rate where you can actually handle that in a software application, and you'll get it reported back to you. So we are integrated with a lot of ag apps, and I think that sort of what I would say about that is right now we're integrated in a way where the ag apps use the imagery really as a map, and they'll do things like take the values out of the imagery and come up with an application rate. And I think that that's a pretty right now I think it's a, compared to where we could be, is a pretty naive use of the imagery. I mean, it's very effective, so don't get me wrong, and we don't need complexity for its own sake, but I think that there's a lot more that we could be doing in terms of looking at actual information in the data, not just single values, and the sort of multi-factor optimized answer, because farming really is an optimization problem. It's both a spatial and it has spatial and temporal dimensions, but as well as like nutritional and climatic dimensions. But it's, at the end of the day, it's an optimization problem. It's inputs, yield minus inputs is profit, and that's, growers are classical profit maximizers. So it's pretty cool. Anyway, the API works and people are integrated with it, but I think there's a huge opportunity to sort of take it to the next level. So have some stuff about sort of how to use an imagery API, but I guess I was hoping to wrap up a few minutes early, which it looks like I might have done. I'd be happy to take questions if there are any questions. So I think one of the things, I guess maybe to riff on Devin's question, is we're not at the point of training models. Like, agriculture's not there yet. State of the art in agriculture is still classical models with, basically based on, not based on machine learning, but based on, sort of a priori agronomic scientific knowledge of like, hey, this is how a plant uses nitrogen. And we are not to the point of doing machine learning optimization at scale, really. So that's probably what's most surprising to me, given the stakes that are on the table. I mean, agriculture is, depending on sort of how you count and who you ask, like a $5 to $10 trillion a year industry, and the average corn grower in the U.S. gets almost exactly 1/4 the yield of the best corn grower. So think about that. 3/4 of the productive capacity, productive potential of the 100 million acres of corn we put in production every year, it just like evaporates to poor, basically to huge opportunity for us, as an industry to do better there. But yeah, I would say that the surprising thing about our models is that they're all classical. It's been a pleasure. I hope it's been a useful discussion, and I hope that I've shown that agriculture has the sort of thing I wanted to communicate is that agriculture has the feedstock, both from imagery providers, but also things like soil and yield maps that are out there. And the documentation is there, but nobody has like put together this this machine learning thing to actually, in an incredible way, help optimize the production problem of too much, too little nitrogen, and sort of adjust those factors. And so I think there's a huge opportunity here. The data's there, and I hope that maybe I've inspired somebody to take a look at this industry or make sure that their generalized machine learning fit agriculture. So thanks very much.